Hello friends, I am Arvind and in this video I'm going to explain a concept called momentum. In this video I'm explaining the concept called momentum because in the following videos I'm going to start with the explanation of the second law of motion. And to understand the second law of motion, we need to understand momentum. So let's start with momentum, right? Momentum. Please, don't mind my handwriting. So this is denoted with the letter P. Now, why is it denoted with the letter P? Because M is already used for the letter for the quantity mass, and we can't use the same letter for momentum because it might create a confusion. And hence, we use the letter P. So let's start. Now, let's take an example to understand this concept. We have a road, right? Now, in this road, you are a loner standing here. There's no one for support, right? Now, you have two adjoining hills on both the sides. Wait, I'll draw it in a much better fashion. So one and two, right? And from here, there's a cycle approaching, and from here, there's a truck approaching, right? A truck. Now, let's say the mass of truck is m2 and the cycle is m1. So we know clearly that there's no cycle's mass which is greater than the truck's. So m2 is greater than m1, correct? Now, let's say they have the same velocities. So v1 is of cycle equal to v2. This is the first case. Now you tell me guys, from which vehicle would you save yourself? The truck or the cycle? You would save yourself from the truck because it's massive and it might create a greater impact on you, right? Now if it has a huger mass, if it has a big mass, then it has a greater momentum, and that momentum will create a danger on your body, danger in your body. So we can say momentum is dependent on a factor, mass. So more the mass, more the momentum. Excuse me. So more the mass, more the momentum. This is the first equation which we derived from understanding, right? Now let's take another case, right? So the same example itself, we have m2, which is the truck's mass, is greater than m1. Now let's say the velocities are different. Oh, sorry. The velocities are different, right? Now, if the velocity of the cycle is v1 and the velocity of the truck is v2, then let's say for this case v1 is greater than v2, right? Now, if the truck is emerging slowly towards you, the cycle is coming in a faster way, much faster rate, then you tell me, will you have the time to save yourself from the cycle or the truck? The time for saving yourself from the truck would be more, right? So you would save yourself from the truck because it's coming in a much slower fashion than the cycle. If you would have saved yourself from the truck, and if you would have saved yourself, from the cycle by blocking the cycle, then it would have created a much greater impact on you than the truck, right? So we can say that momentum is dependent on another factor called velocity, and we can say that momentum is proportional to velocity. More the velocity, more the momentum, right? Now, if we have these two equations, according to the law of proportionality, right? This is the law, right? So when you have the same quantity in the left hand side, then you can multiply the right hand side terms. So we can say that momentum is proportional to mass into velocity. Now to break this proportionality sign, we add a constant to the right hand side and multiply it with the right hand side terms. So let's assume the constant to be k times mv. right? K times mv. Now, for this case, we have to assume the value of k to be 1 because the momentum's SI unit has to be kg meter per second. So we have to take the, you know, constant velocity, constant as 1 and multiply it with mv, it will become 1 into mv, which is nothing but mv, right? Now, the SI units. Let's go to the units now. SI units. SI unit, what is the SI unit of mass kg? Times. SI unit of velocity is meter per second. So SI unit is meter per second. Now, in CGS, what is CGS? CGS is centimeter gram second. This is a system where you can use units which are relative to centimeters, grams, right? So we can write the unit of momentum in CGS as grams centimeters per second, right? Now let me give you one numerical problem so that you understand everything clearly, right? I'll give you two of them which are very simple. So yeah, fine. Now let's say there's a mass, there's an object, okay, with mass, let's say 10 kg, right? Mass of 10 kg. Now it's moving with a velocity of, let's say, 6 meter per second. Right? Simple question, what is the momentum? If you want, you can pause the video and tell, but it's really simple maths. You can do it mentally. It's just 60 kg meter per second. Never forget the units, people. Units are very important. It defines what quantity are you measuring, right? Now, what if this was in grams? Then you would have converted into kg and multiplied, right? So always converting is very important. There are two systems, MKS and CGS. MKS deals with, uh, MKS deals with a different set of units and CGS deals with a different set of units. So you have to multiply the same units whenever you're doing the math, right? So this is a pretty easy question. Let's say now it's moving with a velocity v and the momentum is given to you as 60. You would easily divide 60 and 10 and tell me the answer of v as 6, right? So let's do it. P equals to mv, correct? Now we have 60. So let's substitute the values. 60 equals to mv, correct? Now mass is 10, mass is 10, correct? Into v. So obviously we clearly here is 6, right? I don't need to do the calculation again. Now people, sorry. Now people observe that momentum is a vector quantity, right? Sorry. Momentum is a vector quantity. Why is it a vector quantity? Because velocity is a vector quantity and this is a scalar quantity. So when you're multiplying a scalar and vector, it is always a vector, right? So momentum is a vector. What is a vector quantity? A vector quantity is a quantity that defines both magnitude as well as direction. It has both magnitude and direction, and that's an important thing to note. Right? So yeah, this is it. Thank you.